Hi, we're Group 13, and we partnered with Nestlé Purina's plant in Clinton, Iowa, to improve their small packaging lines for our senior design project. After meeting with the team at Purina, we learned that line 6 is the oldest and most problematic line in the small packaging department. Using this information, we developed this list of objectives in order to increase the production capacity of line 6.
During the current state analysis phase of this project, our team observed line 6 for 12 operating hours and conducted a hybrid between a time study and a work sampling study that focused on unplanned downtime. Our team also received red zone data for line 6 from the last quarter, which records all of the unplanned stops that occurred during scheduled operating times. Using the data we gathered as well as the data provided by Purina, we performed Pareto analyses in order to validate the data we received from Purina, determine where most of the problems were occurring, and determine where to focus our efforts in the future state design of this project.
After data analysis, the team found the following solutions to achieve the project objectives. Safety is number one at Purina. With this in mind, the team observed safety concerns at both the hopper and bag hanger. The current gap at the hopper is 2 3/4 inch and 4.5 inches from the nearest hazard. The current gap at the bag hanger doors is 2 inches and 14 inches from the nearest hazard. This does not follow the Nestlé Purina Pet Care Safety Distance Standard. To solve these safety concerns, the team recommends to replace the guarding around the hopper with guarding similar to what is seen on line 22 on the right-hand side in the top right corner. On the doors, the team suggested adding a piece of material to cover the existing gap. There are plans in place to implement both of these safety improvements currently. A large amount of unplanned stops were seen at the bag hanger specifically. Many stops occurred when bags would tip after being pushed onto the first conveyor by a piston. To help prevent bags from tipping and thus decrease unplanned stops, the team suggested to Purina to lower the height of the platform which bags are pushed off and add a support to the side of the piston. A support on the side would catch bags as they begin to tip. Lowering the platform would make the drop smaller for bags as they move onto the conveyance, making them less susceptible to tipping.
The center lines at Purina are used as the standard operational settings for the machinery on each line. Previously, center lines were reset after 3 to 4 runs and held no real history of the line's performance. With the new center line sheet being implemented, more runs will be used to collect data in order to determine the best operational setting. Also, the operational efficiency for each run will be recorded in order to build a log that shows the best settings to use for each SKU that is run on the line. This will be implemented across the entire small packaging department.
Next is the film sealers in the EDL bundler. Out of the 2 sealers, Sealer 1 has been the most problematic. The solution to this is adding a roller to the lower jaw of the sealer. This way, the design will mimic Sealer 2 and reduce the amount of unplanned stops. For the back clamp in the EDL bundler, our solution to reduce the number of unplanned stops was to review the current PLC timer settings and adjust them in order to reduce the back clamp's reaction time. This is so it can stop bags before they can cause jams in the collation area.
The last improvement implemented for this project regarded changing the conveyor joints at 2 locations where bags often got stuck. The first was entering the metering and conditioning conveyor where a flat plate was in place. However, the angle of the flat plate caused bags to get beached and pile up. The entering conveyor was then raised and the flat plate was adjusted to an angle that allows bags to easily move on to the next conveyor. The other area was entering collation where there were 4 small free-moving rollers. The change implemented was replacing the small rollers with another flat plate set at an angle similar to the joint entering metering and conditioning. The economic impact of this project was estimated to have a 3-year net present value totaling roughly $3.1 million in extra production capacity. With the estimated implementation costs totaling only $7,200, our team calculated the 3/4 return on investment to be 10,674%, with a payback period for this project being less than 1 week. Thank you for listening to our senior design presentation.